Hi, 8th graders. It's Mrs. Thompson, and we're going to learn our second strategy today in section 5.2, example 1. We're going to solve systems of linear equations by substitution. Remember what we did the day before. We learned how to solve systems of linear equations by graphing. Now, I will admit to you, I do not like that particular strategy. I would much rather either substitute or our third strategy, which we'll learn later on in the week, which is called elimination. So again, to review one more time, what was the first strategy we learned for solving systems of equations? We graphed. You're exactly right. We did graphing. Not my favorite. Maybe some of you like it, but I certainly don't. It's not my favorite. All right, so let's look at example 1. We're solving a system of linear equations by substitution. And we've got several examples I want to show you. So first of all, do you recognize that you have a system here? Hopefully you say, yes, we recognize it. Because I have two equations here. I have y equals 2x, and I also have y equals x plus 5. Okay? Now the cool thing about substitution, and this is one scenario I would definitely use substitution hands down every time. Do you see how y has this name? Y has the name 2x. Y is also known by the name x plus 5. So the point I'm trying to make here is I want us to use our logic. If y is equal to 2x and y is also equal to x plus 5, then logic says these two should also be equal to each other. They are both y, and y equals itself, so 2x should equal x plus 5. And so this is a really cool way to solve it because this totally eliminates the y's right off the bat, and all you have to do is rearrange the equation solving for x. So let's get our x's on one side. Here we go. And I've got x equals 5. Well, that's great. Some of you might think, whew, I'm done. That was easy. Well, we're not quite done because remember, we're looking for the point of intersection. We only found the first part of that. We now know that x is equal to 5. So now what we need to do is go back to the original equations, either the y equals 2x or the y equals x plus 5, and we need to substitute our x in and solve for that y. You can do it with either one. If you choose to do y equals 2x, then you would do 2 times 5, which is 10. Or you could do, with the other one, y equals x plus 5, plug our 5 in, and 5 plus 5 is equal to 10 as well. It doesn't matter. My point is it doesn't matter. You don't need to do both of them. You just need to plug into one of them and solve for y. So our point of intersection is at 5, 10 for this first system. Okay? And you can plug it in and just test it out if you want to. If it doesn't work in both of them, then that's not your solution. Okay? I love doing substitution, especially when the equations are set up this way. Let's look at B, because B is set up similarly. You see, in B, y is x plus 3, but it's also 2x plus 5. So that means they are equal to each other. They're both y, so that means y is equal to itself. So these two things must be equal to each other. So let's get our x's together. It doesn't matter if you move the 2x or the x like I just did. And I've got 3 equals x plus 5, and then I'll subtract 5 from each side. And it looks like x is negative 2. That's great. You're not done, okay? You are not done. So pick the equation from the original 2 up here. Pick one of the original 2 equations, and whichever one looks easier, and plug into it. Now, me doing the problem, I would choose the x plus 3. I think that looks a little easier. Plug in negative 2 for the x and solve. And negative 2 plus 3 is 1. And so your point of intersection is x is negative 2, y is positive 1. There's your point of intersection. Boy, it beats the heck out of graphing, doesn't it? We got those done a lot faster. All right, let's flip to our next page. Now, of course, they're going to try and stymie you a little bit. You can see that we don't have y-intercept right there in that first equation. We have standard form. So that's simple. Just change it so that it's in slope-intercept form. Take away 2x from each side, and you've got y equals negative 2x plus 5. Now it's in slope-intercept form, and so if that's equal to y, x minus 4 is y, and negative 2x plus 5 is y, then that must mean that these two things are equal to each other. You're exactly right. You're doing a great job. And so you're going to get your x's together. There they go. We got negative 3x plus 5 is equal to negative 4. Take away 5. We've got negative 3x is equal to negative 9. And so that means x is 3. Now please don't think that you are finished, because you are not. You found 1/2 of your point that we're looking for, the point of intersection. So pick one of the two original equations. That one does not make me happy. This one, yes, that puts a smile on my face. That looks easy. So we're going to take 3, plug it in for the x, and solve. So it looks like y is negative 1. So my point of intersection, x is 3, y is negative 1, and there's my point of intersection, 3, negative 1. So far, is this seeming pretty easy? I really do like it when they are already solved for either x or the y. When I have to do rearranging, I don't like this particular method, but I'm showing you how to do it in case you do happen to latch onto it. Okay, let's look at D. Notice this time they solved for x. Okay, let's use our logic. Would that be a good idea to do here in the second one, solve for x? If you said yes, I totally agree with you. And let's get x plus 8y. Let's get that so that x is by itself. Because it doesn't always have to be y by itself. It can be that the x's are by themselves. So, all right, I'm going to take away 8y from each side. So now I have 16 minus 8y. That's x. And so is this. So I have x has another name, 2y minus 4, and x is also 16 minus 8y. So you can set those equal to each other. They are equivalent because they both equal x. And it's okay if you solve for x and not for y in both of them. Now what you don't want to do is solve for x in one and solve for y in the other. They're not the same. You can't do that. So solve either both of them for x or both of them for y. Whatever makes sense and is easier to do in both. Okay, let's get our y's together. So I'm going to add 8y to each side. Here we go. I got 10y minus 4 is equal to 16. Okay, that looks good. And then let's add 4 to each side. So I got 10y is equal to 20. And when I divide by 10, that means y is 2. Not x is 2, y is 2. So that's actually the second half of my point. I don't know the first half, so I need to pick one of these to plug into. I'm probably going to use that very first one. That one just looks easier to me. So I'm going to do 2 times 2 minus 4. Well, 2 times 2 is 4, and 4 minus 4 is 0. So we're saying that x is 0. So you need to put that number first. Even though I solved it and got that number second, that's the x. X always goes first in the point, and then my y is 2. So the point of intersection is 0, 2. All right, let's flip the page. More of the same. You just need to make a decision in letter E, which variable makes more sense to solve for. Now, what I look for as a math student is I look for the variable that does not have a coefficient in front of it. Notice that in this one, x doesn't have a coefficient other than 1. That's okay. That's okay to have in front of it. And there's also a 1 in front of the x in the other one. So what that tells me is that's probably the best idea is to solve for x in each. So for x plus 4y equals 6, I'm going to take 4y and move it over to the other side and rename it so that x's other name is 6 minus 4y. And then I'm going to do the same thing in this other one. Take away y, and then I've got x equals 3 minus y. So if that is another name for x, and so is this, then 6 minus 4y and 3 minus y, they must be equal to each other. They both equal x, they must equal each other, and they do. So let's add 4y to each side. Okay, and I've got 6 equals 3 plus 3y. And then let's take away 3 from each side. And I've got 3 equals 3y. Divide each side by 3. So y is 1. So again, I found the y first. That doesn't mean that number comes first in the point. I just found it first. That's all it means. Now, go back to the original equations. I like this one. That one looks easy to me. And x plus y equals 3. X plus 1 is equal to 3. Take away 1, and we're saying x is 2. So your point of intersection, remember, start with the x. That would be 2. And then your y, which is 1. So my point of intersection is 2, 1. I hope you're following along with me and that it's making sense. Now f, both of them are in standard form, but like I told you previously, when I do this and I want to do substitution and I need to rearrange, I'm going to look for the variable in both equations that has a 1 in front of it, if possible. Sometimes that's not possible. Well, there's a 1 in front of the y, and there's a 1 in front of that y. So I'm sold. We're going to solve for y in both. Okay? So we got 2x plus y equals negative 4, and I am going to take away 2x from each side. Okay? So now I got y equals negative 2x minus 4. Let's do the same thing here. We're going to take x away from each side. And I got y equals negative x minus 7. Now both of these quantities right here that I have circled, they both equal y. So that means they have to equal each other. So negative 2x minus 4 must equal negative x minus 7. Wonderful. Let's start solving this thing. I'm going to add 2x to each side. Super. Gone. And I got negative 4 is equal to x minus 7, and then I'll add 7 to each side. Beautiful. I bet you're already ahead of me and you already know the answer. So we just solved the first half of the point. We found the x value, but I need the y value. So you just choose whichever original equation looks easier for you to plug into. Now I like that one. X plus y equals negative 7 just seems not as complicated. So I'm going to take away 3 from each side, and it looks like y is negative 10. So it looks like my point is 3, negative 10. And there you go. So I've done 6 of these with you. Hopefully I've made perfect sense and that you like this strategy. It beats the heck out of graphing every day of the week. So bring your questions to class tomorrow if you have any, okay? Thanks for listening.